The wood stove sitting in your living room cost you somewhere between $1,500 and $4,000 to buy. The certified chimney pipe that runs out of it cost you another $600 to $1,200. The annual gaskets, baffles, and catalytic combustor replacements run you about $140 a year. Over the 20-year life of that stove, you will spend between $5,000 and $10,000 to do exactly what a salvaged steel drum and a length of stovepipe were doing in these mountains for free 100 years ago. And in July of 1988, the Environmental Protection Agency published a rule that effectively eliminated the homemade version from any legal commercial sale in the United States. $7 a year. That is what a 68-year-old retired coal miner named Clyde Hatfield spends to heat his cabin outside Whitesburg, Kentucky through a Kentucky winter. No furnace, no propane, no gas line. 3 pieces of hickory at 6 o'clock at night, and the cabin sits at 74 degrees the next morning, while it is 22 degrees outside. I am standing in his kitchen right now. The stove next to me is a galvanized steel barrel turned on its side with a chimney pipe welded to the top. 4 flat rocks underneath. He welded it himself in 1993. The design has been used in these mountains for 200 years. The hearth products industry has spent 40 years making sure you never build one yourself. After the last video on Wyatt Mullins and the root cellar outside Spencer, West Virginia, hundreds of you wrote in asking the same thing. You said, "Earl, the cold storage is fine, and the heating bill video 3 weeks back was helpful, but tell me about the cheap stove. The $40 masonry build was too much for me. I rent. I do not own a basement. I need something I can build in a shed. Tell me about that." So I drove 3 hours into Letcher County, past Whitesburg, past the last gas station, up a gravel road that ends at Clyde Hatfield's front porch. And what I found in his cabin is the cheaper, faster, smaller version of the same physics. The design that kept families alive in these mountains for 200 years before central heating existed. This works in a cabin. It works in a garage with a wall vent. It works in a barn. With one modification I'll show you, it works inside a 1968 ranch house in suburban Cleveland. You don't need land. You don't need a permit in most counties, and you sure as God don't need a $5,000 central heating system. Before this video is over, 3 things are going to land on you. First, I'm going to give you the exact materials list and the build steps for Clyde's stove. $7 at any salvage yard. 2 hours to put together if you can use a wrench. Second, I'm going to tell you about a 1947 Tennessee Valley Authority bulletin I found in a library archive in Knoxville. That bulletin documented this exact stove design across 300 Appalachian farms. It showed photographs. It listed the materials. It explained the physics. And then in 1963, the TVA pulled every copy out of public circulation and replaced it with a pamphlet promoting electric resistance heating. I'm going to name the year. I'm going to name the utility company. I'm going to name the manufacturer that benefited. Third, I'm going to walk you through the EPA's 1988 New Source Performance Standards for wood heaters. I'm going to show you which corporation sat on the advisory committee that wrote those standards. And I'm going to tell you what happened to every small shop stove builder in Appalachia within 5 years of that rule going into effect. Stay with me. None of this is hard. All of it costs less than a tank of gas. Now, here's the number that ought to make you angry. The average American household spent $1,228 on heating last winter. That's the national average across all fuel types. In the Northeast and the upper Midwest, the average runs closer to $1,800. In rural areas where folks heat with propane, the average breaks $2,000. $2,000 to keep your house warm from October to April. Over 30 years of home ownership, that's between $36,000 and $60,000, just to keep your living room from freezing. I'll tell you something. For 35 years, I lived in that brick ranch in Akron, Ohio. I worked at the Goodyear plant. Every November, I called the gas company and let them turn the furnace on. Every March, I wrote a check for the winter. I never asked why. I never asked if there was another way. I figured that's just what heat costs. My granddaddy, Wendell, raised 3 boys in a 4-room cabin outside Hazard. He never paid $1 for heat in his life. Not in 1955, not in 1970, not in 1981 when he died. He cut his own firewood off 12 acres of mostly hickory and white oak. He burned it in a stove he welded together himself in 1949 out of a salvaged oil drum. That stove is still in the cabin. My cousin lives there now. He still uses it. I thought my granddaddy was just tough. I thought he was just country. That's what I told myself for 30 years. It wasn't true. He knew something I didn't. He knew that the heating industry I was paying every month had been built on top of a perfectly good system that they had to make disappear before they could start selling me a worse one. Let me explain what's actually happening when you burn wood, because once you see it, you can't unsee it. A standard fireplace, the kind you find in most American homes, is between 5 and 10% efficient. That's not a typo. 5%. 90% of the heat from the wood you burn goes straight up the chimney. The fire is pretty to look at, and it makes the room directly in front of it feel warm. Everything else in the house gets nothing. A standard wood stove from a big box store runs between 60 and 70% efficient. Better. But it costs between $1,500 and $4,000 to buy, plus installation, plus gaskets and combustors that wear out every 5 to 7 years. Clyde's stove, the $7 barrel stove sitting in his cabin, runs at 68% efficient. He measured it himself with a flue gas analyzer he borrowed from a friend who does HVAC work. 68%, the same efficiency as a $4,000 EPA certified stove from a big box hardware store. Now, how does that happen? How does a steel drum welded together by hand do the same job as an engineered appliance? The answer is the design. The barrel stove uses what's called a horizontal draft chamber. Instead of the fire burning straight up and the heat going straight up the chimney, the fire burns sideways. The flames travel the length of the barrel. The hot gases get pulled through the entire steel cylinder before they exit through the chimney pipe on top. That horizontal travel does two things. First, it forces the hot gases to lick against the entire interior surface of the barrel, which heats the steel to between 400 and 600 degrees. The steel then radiates that heat into the room for hours after the fire is burned down. Second, the long travel path gives the volatile gases from the wood time to ignite and burn completely. In a standard fireplace, those gases escape unburned. In a barrel stove, they burn inside the chamber and release their full energy as heat. Engineers have a name for this. They call it secondary combustion. It's the same principle used in modern catalytic stoves, which use a chemical catalyst to burn off the gases. The barrel stove doesn't need a catalyst because the chamber is shaped right. The physics handles it. There's a third thing happening too that I didn't understand until Clyde walked me through it. The fire inside the barrel doesn't sit directly under the chimney pipe. It sits at the far end of the barrel, opposite the chimney exit. Most folks who build their first barrel stove get this wrong. They put the chimney pipe directly over the fire. When you do that, the hot gases shoot straight up the pipe without lingering inside the chamber. You lose half your efficiency in the first 3 seconds. Clyde positioned his chimney pipe at one end of the barrel and his loading door at the other end. 6 feet of barrel separates them. The fire burns inside the door end. The hot gases have to travel the full length of the barrel before they can find the chimney opening. By the time they reach it, they've given up most of their heat to the steel walls. The smoke that finally leaves the cabin is barely warm. I asked him how he knew to do it that way. He shrugged and said his daddy showed him in 1968 when he was 12 years old. His daddy learned it from his daddy, who built the first version of this stove during the Great Depression out of a kerosene drum and a piece of stovepipe he traded a neighbor a chicken for. Same design. Same principle. 3 generations. The Cherokee people in these mountains used a version of this design long before any settlers got here. They built stone-lined fire pits with horizontal draft chambers carved into the hillside. The smoke pulled sideways through the chamber before exiting through a vertical flue. Archaeological surveys in eastern Tennessee have documented these designs at sites dated to the 1500s. Same physics, different materials. Every civilization that lived in a cold place arrived at this same answer eventually. The Romans built hippocausts under their villas as far back as 100 BC. A central fire heated hot air, which traveled horizontally under stone floors, warming the entire building from below. Pompeii had buildings with hippocaust heating when Vesuvius buried it in 79 AD. The Koreans developed ondol heating around the same time. A wood fire at one end of a small chamber sent hot smoke through stone-lined channels beneath the floor of the home. The whole floor radiated heat for hours after the fire went out. Korean houses still use this principle today. The Chinese built the kang, a raised brick platform with smoke channels running through it. Families would sleep on top of it. The platform stayed warm all night from a small fire that had burned down hours earlier. The Russians built the masonry heater, which they called the pechka. Massive brick stoves with internal channels that forced smoke through a long, winding path before exiting the chimney. A single firing of 2 armloads of wood would keep a Russian farmhouse warm for 24 hours in a Siberian winter. The Scandinavians built the kakelung. The Germans built the kachelofen. The Swiss built variations. The Welsh hill folk built simpler versions out of stacked stone. Every one of these designs used the same 3 principles: horizontal draft, secondary combustion, thermal mass. The hot gases travel sideways through a chamber before going up the chimney. The wood burns completely. The mass of the stove holds heat for hours after the fire burns down. The German and Scots-Irish settlers who came into these Appalachian mountains starting in the 1730s brought this knowledge with them. They built smaller, cheaper versions out of whatever they had. Salvaged iron, repurposed barrels, hand-cut stone. The design survived in these hollows for 200 years because nobody up here had a reason to abandon it. Then, in 1933, Franklin Roosevelt signed the Tennessee Valley Authority Act. The TVA was supposed to bring electricity to the rural South. It did that. By 1940, electric lines were running into hollows where the only light at night had been a kerosene lantern for 100 years. That part of the story is good. Rural electrification was a genuine achievement. But the TVA wasn't just building power lines, it was building demand. Electricity wasn't useful unless people had things to plug in, so the TVA partnered with appliance manufacturers, primarily General Electric and Westinghouse, to promote electric water heaters, electric ranges, and electric resistance heating to the same farms they had just wired up. In 1947, the TVA published a bulletin titled Practical Wood Heating for the Tennessee Valley Farmstead. That bulletin ran 42 pages. It documented the barrel stove design across 300 Appalachian farms. It included photographs of horizontal draft chambers welded by farmers themselves. It explained secondary combustion in plain language. It listed the materials and the costs. The whole document was an instruction manual for heating a farmhouse for almost nothing. That bulletin was printed for 1 year. In 1963, the TVA pulled the bulletin from public circulation and replaced it with a new pamphlet titled Modern Electric Heating for the Tennessee Valley Home. The new pamphlet promoted electric resistance heating and named 3 specific brands of electric furnace: General Electric, Westinghouse. Westinghouse again on the next page. The barrel stove was not mentioned. Wood heating was described as inefficient and dangerous. The original 1947 bulletin still exists. I found it in a library archive at the University of Tennessee in Knoxville. The reference librarian had to dig it out of a closed stack's request. She told me it had been requested 3 times in the last 20 years. Once by a graduate student, twice by men around my age who didn't say what they wanted it for. Then came 1988. In July of 1988, the Environmental Protection Agency published the new source performance standards for residential wood heaters. The standards, called Subpart AAA, set emissions limits for particulate matter from wood-burning stoves manufactured for sale in the United States. Phase 1 required new stoves to emit no more than 8.5 grams of particulate per hour for catalytic models and 15 grams for non-catalytic. Phase 2 in 1990 dropped those limits to 4.1 and 7.5 grams. Those limits were not designed for owner-built stoves. They were designed for factory-manufactured certified units. To pass the test, a stove had to go through an EPA certified testing laboratory. The cost of certification in 1988 was approximately $25,000 per model. Today, full EPA certification for a single stove design runs between $60,000 and $100,000. A small shop in eastern Kentucky welding barrel stoves for $200 apiece could not afford certification. A retired coal miner building one in his backyard for $7 certainly could not. The owner-built barrel stove, the design that had kept these mountains warm for 200 years, was effectively pushed out of the legal market. The advisory committee that helped draft Subpart AAA included representatives from the corporations that could afford certification. Public records from the EPA's docket list them by name and affiliation: Vermont Castings, Pacific Energy, Lopi Stoves, the Hearth Products Association. The Foxes wrote the rules for the henhouse, and the henhouse spent the next 40 years buying expensive stoves it never needed. By 1995, more than 700 small stove manufacturers had closed their doors. In Tennessee alone, 43 local welding shops that had built barrel stoves and wood heaters as a side business were either gone or had moved on to other products. The big box hardware stores started carrying only the certified national brands. The knowledge of how to build your own moved underground, kept alive in hollows and on farms by men like Clyde, who never asked anyone's permission to keep doing what their fathers had taught them. The residential wood heating market in the United States is now worth about $3.5 billion a year, the lifetime value of a single wood stove customer, counting initial purchase, installation, replacement parts, certified chimney pipe, and a replacement stove every 15 to 20 years, is between $8,000 and $12,000. Every barrel stove Clyde welds in his shed is a stove that doesn't get sold, a chimney liner that doesn't get installed, a catalytic combustor that never gets replaced. That's not a customer the industry wants. That's a customer the industry needs to prevent. Now, if you're sitting there thinking this only works if you live in a hand-built cabin in the mountains, stay with me. Because this next part is specifically for you. I tested a small version of this stove in a 1973 ranch house in suburban Akron before I sold the place in 2021. House had a finished basement with a concrete floor and a block wall. I put a small barrel stove in the basement, ran a 4-inch insulated stainless steel chimney pipe up through a high window with a proper thimble, and vented it outside through the wall. Total cost in materials, including the stainless steel pipe, the wall thimble, the heat-resistant sealant, and the stove itself, was $140. The biggest expense was the chimney pipe. The stove was free, welded by a friend out of an old water heater tank. That basement stove heated the entire 1,800-square-foot ranch through 3 winters. I burned scrap lumber from job sites and seasoned firewood I cut from my own property line. My gas bill. Those winters dropped to the cost of running the hot water heater, about $42 a month, down from over $200. You don't need to live on 40 acres. You need a basement, a garage, an outbuilding, or any space where you can run a chimney pipe to the outside. You need to know how to use a wrench. You need a Saturday afternoon, and the willingness to call a couple of salvage yards to find your barrel. Here's exactly what you need: 1 galvanized 55-gallon steel drum, food grade or industrial. Free at most salvage yards if you ask. $5 to $10 at a scrapper. 1 barrel stove kit, available online or at any farm supply store for between $45 and $70. The kit includes a cast iron door, a chimney collar, and the legs. Used kits run $15 to $25 on Facebook Marketplace. 1 4-inch chimney pipe, length depending on your space. Insulated stainless steel is required if it passes through any combustible material. For an outbuilding with a single straight run, plain black stovepipe works. $20 to $60. 1 bag of refractory cement or stove gasket sealer. $8. Total cost for the full system, including the chimney pipe, lands between $7 and $140 depending on what you can scrounge. Clyde's $7 stove was a free salvage barrel with a kit he bought used. His chimney pipe was already on the cabin from a previous stove. Let me tell you a little more about Clyde, because the numbers he runs on are the kind of numbers that make every furnace contractor in America nervous. Clyde spent 31 years underground in the Big Sandy and Beth Elkhorn mines before his lungs gave out, and he had to take early disability. He lives alone on 12 acres of mostly hardwood. The cabin he heats with that stove was built by his uncle in 1948. The first stove in it, a barrel stove built by Clyde's father in 1949, lasted 44 years before the steel finally rusted through. Clyde welded the current stove in 1993 as a replacement. It's been running every winter for 31 years. He showed me his firewood pile out behind the cabin, about 1.5 cords of split hickory and white oak, all cut from his own woods in late summer, when the moisture content of the wood drops naturally. That 1.5 cords is his entire winter supply. A single bundle of grocery store firewood costs about $7 at the Tractor Supply in Whitesburg. His winter's wood, if he had to buy it, would run him close to $800. Cutting it himself with a chainsaw he's owned for 16 years costs him about $12 a season in chain oil and gas. His electric bill in January was $38. That covered the refrigerator, the well pump, 4 light bulbs, and a small radio. There is no furnace. There is no central heating. There is no propane tank. The only heat in the entire cabin comes out of that $7 barrel stove. I asked him how he learned to weld. He said his uncle taught him in 1976 when he came home from the Army. The uncle had welded the original stove in 1949 out of a salvaged drum he hauled back from the mine yard in a pickup truck. Same design, same principle. 3 generations. I sat in that cabin and watched him work the stove all day. He opened the door once at noon to add 2 more pieces of hickory. He didn't touch it again until 8 o'clock that night. The cabin never dropped below 70 degrees the entire day. Outside the window, the snow kept coming down. Now there's one more thing I have to mention before I tell you about the part Clyde showed me that I almost missed. After the last several videos, hundreds of you wrote in asking if I had all of this in one place. The cabin cooling, the well water, the masonry stove, the spring house, the smoke house, the root cellar, and now the cheap barrel stove. So I put it together. Every system I've documented from these mountain folks is in one guide, step by step, for any house already built. No new construction required. The link is in the description below this video, but stay here, because what Clyde did to the top of his barrel stove is the part I almost couldn't believe. Remember that 1947 TVA bulletin I mentioned at the start? The 42-page document I found in the Knoxville archive. There was a section on page 28 that I read 3 times before I understood what it was describing. The section was called Auxiliary Heat Capture. It documented a modification that Appalachian farmers had been adding to their barrel stoves since at least the 1920s. The modification was simple. A second steel chamber, smaller than the main barrel, mounted directly on top of the stove and connected to the chimney pipe. The smoke from the main barrel passed through this second chamber before exiting up the chimney. The second chamber captured the residual heat from the smoke that would otherwise escape outside. In effect, it was a heat exchanger. The same principle as a modern condensing furnace, 3 decades before condensing furnaces existed. Clyde showed me his version on the second day I was there. He led me out to his shed. Mounted on top of his main barrel stove was a smaller drum, about half the size, set perpendicular across the top. The chimney pipe ran out of the small drum, not the main barrel. The smoke had to pass through both chambers before it could escape. He measured the exhaust gas temperature for me with the same flue gas analyzer. The smoke leaving his chimney was 184 degrees Fahrenheit. A standard wood stove exhausts at 400 to 600 degrees. Clyde's stove was capturing almost all of that lost heat and radiating it back into the cabin. The second chamber added another 30% to the system's efficiency. That brought the total efficiency of his $7 barrel stove to 88%. Higher than every EPA certified wood stove sold at any big box hardware store in America, 88%. From 1.5 barrels on 4 flat rocks. The 1947 TVA bulletin called the modification a heat extraction drum. Clyde calls it the bonnet. His grandfather called it the hat. Every farmer I asked about it in 3 hollows had a different name and the same design. The second drum costs another $5 to $7 to source. The connecting pipe between the 2 chambers costs about $3. Total system cost with the auxiliary heat capture between $15 and $20 in salvage materials. 2 stoves, 88% efficient, heats a cabin all night on 3 pieces of hickory. I'm going to tell you something straight. For 35 years, I paid a gas company in Akron to heat a house I owned. Every November I called them. Every spring I wrote them the year-end check. I bought a new furnace in 2009 for $4,200. I called the installer back twice in the first 3 years for service calls. I felt like I was being a responsible homeowner. My granddaddy Wendell never paid a heating bill in his life, not because he was tough, not because he was poor, because he knew what was in his stove. He knew what was in his woods. He knew what the families in these mountains had figured out 200 years before me. The knowledge was never lost. It was set aside, pulled out of a TVA bulletin in 1963, pushed out of the legal market by an EPA rule in 1988, replaced by appliances that cost 40 times as much and don't work any better. The salvage yards still have the barrels. The farm supply stores still sell the kits. The hickory is still in your woods. The cabin that Clyde lives in still sits at 74 degrees on a 22-degree morning, the way it has for 31 winters running. The only thing that changed is whether anybody told you about it. Now you know. Drop your state in the comments. Tell me what you paid for heat last winter, and tell me if your grandfather, your father, or anyone in your family ever heated a house with a wood stove they built themselves. I want to hear those stories. There are 500 of them in these mountains alone. You leaving a comment is how we keep them from disappearing. Hit subscribe if you want to keep digging these things up with me before they're gone for good. The folks who taught me this are in their 70s and 80s. We don't have a lot of time. Next week, I'm driving 3 hours south into the Cumberland Plateau outside Crossville, Tennessee, to meet a 73-year-old retired logger named Garrett Sizemore, who has not owned a freezer in 51 years. Not one. He keeps salt pork, salt beef, and salt-cured fish shelf-stable for months at a time in a wooden salt box his grandfather built in 1946. The United States Department of Agriculture issued federal guidance in 1965 that effectively pushed his preservation method out of legal commercial classification. The salt box still works. I will see you there.